All right, with this activity, this is a copy of one of your exploration activities. You were supposed to note which quadrilaterals fit each category, and you'll notice that some categories were rather open-ended, just has to have four sides, and some got quite specific. So just to help you out, I'm going to fill in what goes in each of those categories, and I'm going to start at the bottom with category 12. And category 12 was all but N. N has this weird bite taken out of it. So what do we call something that has four sides? We call it a quadrilateral. Now let's get more specific. What shapes have four sides where at least one is parallel? There's a lot. B, C, D, E, G, H, I, J, K. Oh, I didn't give myself enough room. There's also M. Now these all have at least one pair parallel. Now, if we limit it to exactly one pair parallel, only B and K fit the bill, because B has these two sides parallel. We often use arrows on sides to show that they're parallel. And K has these two sides parallel. Now, one fun thing is that these are both called trapezoids. Different mathematicians use different definitions for which one's a trapezoid. We're going to use category 10 as our definition of trapezoids. Now, different teachers will use different definitions. You'll have to look at the curriculum you're using to see which one makes more sense for your class when you're teaching. Now, let's look at category 8. Which quadrilaterals have four sides, opposite sides parallel? Well, that's C, D, E, G, H, I, J, and M. And let's look at one of those. Let's look at G. We often mark this like this, where we say we have two arrows going in the same direction. That means those two sides are parallel. And then we'll use two arrows here to show that those sides are parallel. Now, four sides, opposite sides, the same length. That's the same as 8. Category 8 is how we define parallelograms. A parallelogram is a shape with four sides, opposite sides parallel. It just turns out that if you force opposite sides to be parallel, you also get opposite sides the same length. Now, let's look at categories 5, 6, and 7. So 5 is four sides, all the same length. It's C, E, G, I, and J. So let's look at I. One way we notate sides are all the same length is by putting a dash through all the sides that are the same length. Now, if we say all four sides are the same length, but they also need opposite sides parallel, hey, we get the same thing as 5. If we say four sides all the same length, opposite sides parallel, opposite angles the same size, hey, that's the same as 5. Later on in the course, we may show why this is the case, But for right now, we can just observe that it ends up being the case. That if we define a figure as having four sides all the same length, we often get consequences of other things that end up being the same. We call category 5 a rhombus, something where all four sides are the same length. Now, category 6 and 7 are consequences of that, but they're not the definition of a rhombus. When we write a definition of a shape, we want a nice short definition. And if we have four sides all the same length, we get opposite sides parallel and opposite angles the same size. All right, four sides, four right angles. Notice we're not saying those four sides all have to be the same. So that makes category 2 C, D, E, and M. Now, notice that D, it's deliberately placed at a wonky angle where the top side is not parallel to the top of the paper. That's to remind us that orientation doesn't matter when defining a shape. All that matters is attributes. And as you might guess, we call that a rectangle. And category 3 and 4, you may have noticed, are the same as 2. Once again, we want our definition to be as short as possible. And so we use category 2 as our definition of a rectangle, and the other categories are just interesting consequences of that. And as you might expect, category 1 is shapes C and E, and that is our definition of a square.